Missy, how you doing? Good? Chanel? Chanel? Chanel?
Good evening.
Hi, Nestor. How are you? Hi, Nestor.
Hi, sir. Not
How
good,
are you?
sir.
What happened to you?
There are a lot of things, sir. You can look.
No, listen to me now. You're so close to writing those exams. We don't want nothing to go wrong with you. So just relax yourself. You want to go and make some tea? Go and go make some tea and come.
All right.
Yeah, man, go and go make some tea and then relax yourself and just brush it off here, whatever it is. All right?
Okay.
Okay.
Good evening, hi, sir. hope so, because we're gonna hear the funny joke. Mommy?
Hold on,
Mommy?
hold on, hold on. Don't. Sorry, I'm hearing her because I'm trying to connect to this one. No, talk not then.
Yeah. Yeah, you're saying money?
What were you?
I was saying that don't remember. Don't remember what I was saying. Wait. What is this? This is not what I want though. This is not what I want.
Can I see the birds, Mommy?
Huh?
Can I see the birds?
Not from there. I'm not calling from.
Can you put it on video call? Can you answer for video call?
I'm not using something there. I'm not using the what you call it. I have to turn on the video.
Mommy? Can I see the birds? No, I'm not seeing them. I'm not seeing them.
Not see them?
No.
You see them now?
Yes, I am.
Hi Jackson.
Hi, Angel. Hi,
Hi
Jackson.
Angel. Who's talking to you?
Hi, Jackson.
Nesta, you back?
Yes, sir.
Missy, how are you?
Hi, sir.
Calling to
How noisy?
Chanel, you know, oh, your background is noisy?
Yes, sir.
Okay. No, let me call you. And get up, I'm gonna make some tea. Talk to Nesta. Tell Nesta to go make some tea too.
No, sir, we did step away from the computer for a while.
Oh, okay. Hold on. There's some still have the computer running for quite a while.
Did you buy hairspray?
Didn't
Did you buy hairspray?
You're breaking off.
Answer me now. Can you hear me now?
And that's what happened now. But they sit
Can you
down.
hear me now?
I can't hear you.
But they sit down there with the computer.
How do you know I'm saying something?
And guess what? Computer did come in.
Mommy, you're breaking up. Every time when you're saying something, you're breaking up.
All right, take off the camera. Kill the camera. Take off it. Can you hear me now?
Guess what? It's not funny to me. No, God, I can't.
Can you hear me now, Imani?
Yes, Mommy.
Are you hearing me? Let me see your face.
All right.
You're lying. You're not. I'm not breaking up nothing. You're lying. Did you eat something already? I'm hungry. What did you eat?
How the studies going, guys?
Strawberry.
How the studies going?
Oh, luckily you.
Still a study, sir.
Very good. Now listen to me. It's not a lot of us. Right about now, the ones that I see are few. We have to pull through. We have to pull through because
Okay.
Aye. We just have to pull through. That's all I'm gonna say. We have to pull through. So Nestor, Missy wasn't here last week.
No, sir, I wasn't here last class, but I had expressed that I had a family
Yeah,
thing
man.
over
You had a
the
family thing, right?
weekend.
Yeah, man. Right. So I never finished my thought though. So you weren't here. Did you get an opportunity to look at the recording? And that's fine if you say no, you know.
No,
It's
sir.
okay.
No.
All right, that's fine. All right. So what I'm gonna do is tonight I responded to Otterly's request, and I don't understand this computer. It's not shut down either because it's at 61%. So why did it just? Oh, it hibernated. That's what it did. I responded to Nestor's question about me having to do one other topic in preparation for the mid-semester. I looked at looking at the. You hear me?
Yes, sir.
Oh, Nestor, you tell me that should drop off.
Repeat.
She dropped off because I'm talking to her and she's not there.
Yes, sir.
All right. I'm struggling with this Friday night class, you know. Jesus help me. I just want to know through and just call it a day. Normally, I just get frustrated and say, you know what? But I just want to know through and just call it a day. Hold on there. Oh, yes, I did send it off to you guys. I sent something off to you guys regarding the last class, right? With the solutions that we did done.
Yes, sir.
Okay. So I can close this document because I'm finished with this document.
Just that here now, sir. What you say you teach last week?
No, last week we did. Last week I came to do the other topics for the mid semester, but Miss Nestor she come with her our past paper enthusiasm, sir. I was working past papers. I'm proud of her, you know. And sir, I see some question with us. Sir, I can't bother you. And she just do it herself. And then so she do the work and she up on the right track. And she do it herself. So we just spent the time last week to just go through past paper questions. And when I did the past paper question with them, then I found one of my own and gave them to do. Well, next I found one more. And then we work it in class. I gave them the things to them, we work it in class. And yeah, so last week was a good revision week. Today I want to look at the trapezoidal rule. I never did the trapezoidal rule with you guys. So I want to look at the trapezoidal rule with you. It's not difficult. What I want to do is, what should I do, Lord? All right. This is what I want to do for tonight. I want to teach a trapezoidal rule. And when I teach a trapezoidal rule, I want to ask you guys to just maybe find a past paper on any of the topics that we've covered already. And we'll spend maybe 1 hour just looking at some past paper questions and just beefing up our understanding as to what it is in preparation for the next semester. But for now though, I want us to spend some time looking at the trapezoidal rule. Spend some time looking at the trapezoidal rule. And trapezoidal rule is just an application to integration. It really isn't difficult. What it is, however, is you have to be very meticulous when you're doing the area, meaning you can't just do it idly so without even being purpose driven. You have to focus. That's what I'm looking for. That's the word. You have to focus when you do the questionnaire. Because if you lose track, you can run into some difficulties. If you lose track, you can run into some difficulties. So I'm having a challenge tonight because my computer has decided not to be able to connect. It is asking me for something that I don't have. But I know what I'm going to do. Let me see if this is. Let me see something here. No. I can ask you a question outside of calculus too. Everybody here have Wi-Fi. Everybody here have Wi-Fi, don't? At the moment.
Yes, sir.
Let me ask you. You see, do you think it is? Do you think it is fair? Do you think it is unethical? Do you think it is mean? Do you think it is selfish of you having Wi-Fi and then lock it up?
Lock it up?
Yeah, so nobody can get onto it.
Well, sir, if you don't want anybody to tamper with your network or get access to your devices through your Wi-Fi, that's one good reason to lock it up.
Oh, so they can actually tamper with your devices through your Wi-Fi?
Yes, sir.
Okay, all right. So I guess that answers my.
You know, when you connect to a Wi-Fi and the option comes up that asks you, allow this device to be accessed, allow other devices to access this, or something like that. When you're connecting to it for the first time, you don't get that prompt message. Or allow this device to be discoverable.
Yes. Yeah.
I always select no.
Oh. Oh, so I learned something tonight then. Let me tell you why I asked the question though. I learned something tonight. Thank you. Let me tell you why I asked the question. You know, sometimes we'll go to school, like you guys, and we don't have no internet for whatever reason. For whatever reason, your internet is down. Or say just not no internet at all, a data you use to go to school and school online. But your neighbor have little internet and them not did they use it and I say you go overcrowd them system, them not did it, but it lock up. And you know, you can't one of the things for me is when and this is not it's not an indictment on persons who are not able to do what I'm going to talk about. It has nothing to talk about show off. But when I travel to the States, and I have a straight hook up on my phone, and when me do me turn off my mobile data so I not pay for roaming. I not pay for roaming. So I turn off my mobile data. But when I want to touch base with them and say I want a day, I reach, we can't get onto the airport Wi-Fi. We can't get onto the airport Wi-Fi. And if I'm in a situation where I'm going to be renting a car for argument's sake, I'm going to rent a car and I don't have no data, and I go about my business and I say, blow, we're supposed to meet Chanel down there, so I go down there, so I'm not see Chanel. We're supposed to meet Chanel at the mall. I go and I see Chanel at the mall. And if I can't get onto the mall Wi-Fi, I find a Starbucks or a 7-Eleven or a Dunkin' Donuts and I get onto them Wi-Fi free of cost. And I can call and say, Chanel, I'm way there. We have to move up to this. You see, so I mean, we're talking about wanting to be third world versus first world. Why we are looking? Mark, don't get me wrong. Me lock my device too, So don't think of me have mine open. Me lock mine. But mine is locked in a way where one of my neighbors, I said to them, you live alone, you don't need to get no that this is my password for the stuff. Use it Wi-Fi, use the stuff. So to connect them television, that's what them use my Wi-Fi. To connect them whatever, them work from home sometimes. It's my Wi-Fi they use, it not going to cost me anything more, if it's what I'm saying. Right?
Yes,
But
sir, it costs you more.
how?
It slow down your overall network, sir, because more people are stretch your bandwidth. So it slow down your device. Of course, sir, then you notice it. You notice how when you connect a TV via Wi-Fi, it slows down the network, the speed per second.
Well, to be honest with you, I never recognized that before.
You use smart TV, sir?
Yeah.
And you connect it by Wi-Fi or Ethernet cable?
It is connected by the Ethernet cable.
Oh, well, then I don't know then. You try connecting it by Wi-Fi and see if either the TV don't work slow or buffer, or your other devices get slow.
Okay. I don't know.
So the more people depend it, the slower it get. It depends on
Okay.
the service they get from the service provider still. But, yeah.
Sir,
Why? Yes, please. Go ahead.
sir, even though in life you would want to share stuff, what I've come to realize, sir, people take advantage of stuff. For example, we had Wi-Fi, right? And I guess my brother kind of give certain people the password or whatever. I know so then sit down and get I will get her. Like me just feel like that's so
and
extra.
then your network gets slow because you them depend it one time.
Yes, and it's not like
Especially if all of them depend it at the same time.
and I like I use it with something important. I understand if somebody come and say, you know, more log into school or whatever it is, fine. Sir, but as a big grown adult, I feel like say you can get your own
Yeah,
because
but okay, Nesta, I agree with you, know. But suppose I am not in a position, Nesta, to have it. I am grown. I am grown. Me just a start out life. And it's not your fault, you know. Don't tell me that is your fault. And I say that is your fault. Me just a start out life. Me go get one room where I pay $20,000 for. My fortnight salary uh uh at 26. Call it my fortnight salary at $30,000. Make it just a little bit more than minimum wage, which will be $26,000. So them give me $30,000. Right? So me know say out of the $30,000, I have to go put on $15,000 or maybe put on the $20,000 out of the first fortnight. So me know I can pay the rent when we get the second fortnight. I have to take money out of buy food and buy this and buy that. So right about now, internet is in my budget. So me I try a little thing or two. Me can come in and I can check an email and maybe do it. Me don't know. I don't know. I'm just saying it's something that comes to mind a while ago. Not necessarily a while ago. I've often thought about it. Sometimes when I am driving, and this happens to me a lot when I travel. Um, I'm driving and I don't have data when I come to when I go to the people in them country. But when I pass in some stuff, I hear my phone tripping. Why? Because me there was some Wi-Fi where it just connected. And I say, oh, this is going. And I have had because like maybe about 10 years ago. I don't know what happened, but about 2004, I was visiting the States and I was doing something for a student. And those were the days of BlackBerry. I don't know if anybody remember BlackBerry days. And
Black cherry.
Black Cherry, same way. And the student wanted me to do something for them. I couldn't call back to Jamaica. Me not have no data. I free Wi-Fi I could use. So what I had to do was to go and sit down under the Starbucks to get the information. And then the student said, all right, sir, this is that. And then I run, go to the stuff, and then go back to the stuff. And I'm saying to myself, why can't I have data? Why can't we just have, if this is what is running the world, why is it only for some people? Why everybody can't just have access to it? In my view, let me tell you, if I was technology minister, if I was technology minister in Jamaica, all schools should have free Wi-Fi. It's all community centers and park, and it's like all when you go to Port Margaret, and you see you have the big part there. Nobody not even over there go use like all this overgrown with bush. All the community centers, the libraries and in places should have Wi-Fi. The bus them have Wi-Fi.
They're working on all of those things, sir.
Every one of the public transportation them supposed to have Wi-Fi. Every single one of them. Right? So people can, so if you go home from school, you can connect to a little Wi-Fi to go to stuff. You see them register taxi there? The little red pay taxi, the one of them supposed to have Wi-Fi. If we want to develop our country, why slow down? Why you shouldn't can't come to school because you're in commute and you depend on taxi and you don't have no data. Can hotspot something in a one taxi so you cannot listen to the class. You can't participate, but you can listen to what Sir says. So when you read it, listen to the recording afterwards. It makes sense and it comes in a little easier. But anyhow, I guess that's why I'm a technology minister. These are my few words and my few thoughts. I'm going to share the screen now. Finally, sorry. So you go to the bank, and I'm very passionate about this. You go to the bank to go to a transaction, and the people them say you need to do this. and you try log on to your mobile app, and you can't log on because you don't have no data. Why is it that the banks why get so much money out of it in the first place? Can't put in a little Wi-Fi. A free
Sam,
Wi-Fi
every
for them
bank
people.
have went to add Wi-Fi.
You go to the bank and get Wi-Fi from them?
Of course,
Well,
Scotia,
guess what?
JN,
Guess what?
NCB, all of them.
Guess what? Okay, great. I'm happy for that. Because the truth of the matter is this is since COVID come in, I don't go into the banks. All of my transactions are being done now online or through the ABN. So if that is the case, I'm very happy for that. This is the way we're supposed to go. This is the way we're supposed to go in Jamaica.
Oh,
Come on. The way we're supposed to go. All right. I'm just
Yes,
trying
so
to
you know, so
connect.
the banks can have access to your device when they connect to the Wi-Fi, right?
I know that. Public Wi-Fi
Yeah,
in
yeah, yeah,
general.
yeah.
Yeah,
Public
I'm
Wi-Fi in
still
if
general,
they
them have.
want.
So that's why now. So it's if I'm using a public Wi-Fi, you won't get me go on to my banking information.
Sir, you're
No.
not going
Oh,
there. Them can just have access to your phone easily.
Easy,
Sir,
especially if they
yesterday,
save your passwords to
no,
your cloud account.
I don't save my password to my cloud account. There's not one password that is saved to my cloud account.
So you
So
don't
them,
use the remember button for none of your passwords.
no, ma'am.
So you always enter your password every time you log
Yes,
in or anything.
yes, ma'am. And sometimes we get frustrated and I have to put in this every minute. But guess what, ma'am? Every time I'm logging into my thing, I don't put in this up. Let me tell you what is saved. I recognize what is saved to one or two of my banking information. There's not one or two, there's one in particular that is saved is the username. And ever so often I will go and clear it. But for my password, every time I'm putting in my password, I'm accessing the account, I have to literally put in the password. Sometimes them tell me saying I have one more attempt because like different banks have different passwords. And I say, what is this one? So the password that I'm putting in for one bank is a password for another bank. And sometimes I get locked out and I have to go reset the password. Yeah, man, me not
That's
play
a
them
good
games.
thing.
Yeah, man, me not play them games.
Sir, me always
Yeah,
manually enter my password for banking apps, but me attack like other apps. You don't use the remember password for any other
mm-mm.
apps.
No,
Any other
no,
apps.
mm-mm, mm-mm,
Not even
mm-mm,
ECC.
mm-mm. No, no. For my
I'm
email
remember
and something there,
ECC password. We use remember about ECC password. Right now, I
I want
remember what my password.
I
So me
want to
can't
tell you
authenticate my name.
is the other day there is something that them give you for sign on in a school, and I went to somebody's office the other day and I see them put on um I see them just go on and just log on, and I said, but that is so easy. Why just don't do that? And I remember saving one password to that so I can get to go on. And it's a school system. So um even them have to access a VPN in order for go put in that information. So even if them get the password for that, them have to go come to the physical plant to come put in that. And if them come to exit, them not gonna able to do it because them have to go use each person. It's just like what the students are given their email address, and that's what they have to use to log on to the system. Even if them get that password that is saved to the ECC software, them have to go come to the physical plant for putting that the password if it change it. And then also what ECC has done is every 90 days, them change the password. It annoys the crap out of me because every 90 days, I have to go change the password and I keep forgetting it. So every time I have to call them, I say, can you reset my password, please? Can you reset my password, please? But it is what it is. All right. What I want you guys to do for me, I really am begging you. I want you guys to be deliberate in what it is that you're doing, deliberate in your preparations. I am particularly concerned about, well, I've moved beyond my concern as it relates to class attendance. I've moved beyond that, and I'm going to tell you why I moved beyond it. Because I'm expecting that people are responsible enough that if you must miss a class, you're going to go and look at the recording. Even if you don't do it immediately before the next class, but at least it is done. I want my students to be that responsible, right? Because I don't want people to say, sir, nobody teaches, you know. When in fact I did, but you weren't here. I really want you guys to do very well for the mid-semester. I want you to be able to cover your Educasoft pieces. I want you to be able to maximize on your coursework pieces that I've given you. You notice I've given you only 8 pieces of Educasoft. Now I'm gonna get much more than that, you know. I said no summer. Let me reduce it. So I ask Educasoft to do this stuff. I want you guys to maximize so I can go into the exam with about at least 30 out of the 40. Hold on 1 minute.
Sir,
Go ahead.
sir, the one question on Elcosoft, sir. I think something
You know
is
what
wrong.
time? You know what time I open it for you?
No, sir, what I'm saying is the answer is correct.
Maybe it's how you enter the answer. So I will look
No,
back at that for you.
I think so, sir. Because when
You
I
don't
look,
think so?
when I complete it and I look on the solution, it's the exact same thing. No space or anything's missing.
All right. I'll look back at it for you because
Okay.
I'm saying to myself, Lord Jesus, so how long should I do? Well, you have 93% on it.
Yes, sir.
I said, look how long the woman has the 93% on something she don't want to move. So I
No,
thought she
I
just give up
saw it,
on it.
you know, but there's no
Mm-hmm.
point because it's correct.
Mm-hmm. Mm-hmm.
Sir, look on it and tell me.
I will.
Okay.
I will. I will. All right. So are you seeing my screen?
Yes, sir.
All right. So what we have on screen here now is what is called the trapezoidal rule. Did I do that with you before?
Not since this semester, sir,
Hold on.
but before.
So we are looking at the trapezoidal. It's an application to integration. I'm gonna tell you, it's not hard, but like everything else, we have to be focused on what it is that we're doing so that when time comes, we can get it. But I'm gonna tell you straight up, big woman thing, it's not hard. It is not. It is not hard. It is not hard. All right, so trapezoidal. As I say, it's not difficult. It's not difficult. And I want you to just give me an undivided. Allow me to navigate you through
Sorry,
what
sir,
is
just took a call.
happening. Yeah, so I'm about to go through it now, so you don't miss anything much. All right, so just allow me to go through this section with you here. And you should be fine. When I say you should be fine, promise you, I promise you, what I will do is I'm going to go through it, and at different points, I'm going to stop and ask you if you're following me. If there are any gray areas, tell me. Don't let me move on without you doing it, without you seeing it. All right, so let's go. It says that this is a unique, hold on. Let me beautify it somewhat. All right, so this technique is a much more accurate way to approximate area beneath a curve. It's a much more accurate way to approximate the area beneath a curve, right? And you know that when we're integrating, what we're doing, we're finding the area under the curve. And let me tell you a practical way, because I see one of the things that I find is when we know why we do things, it makes life so much easier because we understand the practicality of it. The practicality of what is happening here is when the man them come to you, and trust me, they are ever so rampant now in Jamaica. You have these developers walk road literally and knock on your gate, and you come out and say, "Yeah, how may I help you?" I'm here. Can you give me a minute, please? Yeah, I'm listening. All right. So I'm a developer, and I'm just checking to see if you guys are interested in selling. And then you may have an idea as to why they want to sell the house. And the developer say, you say, you can come back. Him say, all right, who should I ask for? He say, ask for Chanel. And then no, because Nesta knows that Chanel, they say she want to sell something. All right. So when the developer come back now, hear what the developer will say. They are trying to, get into building up a set of apartments, and this plot of land is good enough support and so on. Nesta, Chanel wanted $30 million for the place. But Nesta know, but I want to buy the place from Chanel. And Nesta say, you can pay the 30 million, but guess what? The bank will go take 30 days to process the loan. And then Chanel said, yeah, mom, I'm going to sell some money, but it will sell them. The loan is being processed now. And the developer come in and say, so how much you selling for? And I said, 30. He said, but I can give you $33 million for it. And he said, blow up, I get $3 million more. And then he said, wait, if the man can't offer me $3 million more. And he said, no, man. If me ever broke my sister in foot, I go give her money go try and tell her, I say, boy, all $1 million and see if you can put on for do something else for next day. He said, me give 35 million. And him sell the property. He's selling the property, two man on the property, And you have only one house on the property. Do you know what the man get? The man might get an 8-bedroom, an 8-unit apartment. 4 units are 2-bedroom, and you have 4 1-bedroom units. Them have 8 family multi-dwelling property. And then you say to me, but sir, if the single units take 1 car and the double units take 2 cars, and you have 4 double units, that's going to be 8 cars, and plus the 4 single units, you're going to have 12 cars. But sir, the space of me have right there, so now we able to park 12 cars. Lie I tell. Because what the man them do is to find the area underneath the curve. So what the man them do is now dig deep down to put the car park in the basement. Anybody ever go to a recently developed apartment and see the car park is in the basement? You have to go down in the
Yes,
basement
sir.
to go to the car park? Yeah, man. And that the man them do. So what the man them do now is for the 12 car park, they might find down in the basement, or with them that do is find 8 car park in the basement, and then can find 6 car park up at top.
So the man them say, all right, 4 of the residents I go park up top because what them do, people have them specific parking space. So them say apartment 1, apartment 2, support and so on. And the man then point out, say, oh, you're the plan. Only 2 visitors parking my house. Anybody else come and can't park, I go park out the door. And that's what the man them do. So they calculate the area under the curve. So they can't go all the way too deep, because remember, we have our water table and they have to leave that buffer so that that buffer can support the building, because those buildings will have to be on stilts to support the 2-story or the 3-story. All right. So this is what we talk about with area under the curve. So sometimes they use the trapezoidal rule. And what the trapezoidal rule does is to give them a quick estimate as to the area under the curve. So all those engineers that you see around place, them have to do them areas there. Them have to do it. So when I talk about the area beneath the curve, that's exactly what we talk about. Sometimes I remember there's an apartment that is literally across the road from me. I go up few chains. The back side of it is on my road. So I have to walk on the other avenue in order to access the place. And I said to myself one day, the apartments are now finished. Let me go and look for it. Of course, I wasn't interested because it's $45 million for one of the units. Right? But I know the house that was there before. The house could have taken us about 2 or no more than 3 cars parking there. Big 3-story apartment unit with our swimming pool. And I'm saying to myself, okay, how did they get this? Someone look and say, oh, come on, underground parking. Right? And there are so many apartments that are like that. All right. So now to construct the trapezoids, you're going to mark the height of the function at the beginning and the end of the width interval. So that's what you're going to do. You're going to mark the function at the height. You may not understand that. So I'm going to continue and then I'm going to explain. And then you're going to connect the 2 points. Sir, when I get that, don't worry about it. I'm going to explain to you. So let me just read it one more time. It says to construct the trapezoid, you're going to mark the height of the function at the beginning and the end of the width interval. And then you're going to connect the 2 points. However, the method requires you to memorize a formula. All right. Let me show you now what height we're talking about. So to use a trapezoidal, you're going to draw A all the way up. Boom. You're going to draw the next line up. Boom. And this is what we're talking about, connecting those 2 points. Can you picture that now?
So you can do it again.
Sir.
Let me annotate. So let me show you. So I'm saying to you, let me go up and read again. Oh Lord, no, I'm not going to complain about this computer now because it come up. It says to construct the trapezoids, you're going to mark the height of the function at the beginning and the end of the width interval. The beginning and the end of the width interval. Then you're going to connect the 2 points. You're going to do the height of the function. See it here. The width is the width. This is the width interval. So you can get the other one here, so. And then mark the 2 ends right here. So this piece here, so between A and A1 is 1 trapezoid. And then you can mark another one here, X2. And you can connect a straight line from this point to this point. That gives 2 trapezoids, 1 here, so, and 1 here, so. And then we have the other endpoint that it draw all the way up to the function. Incidentally, this is my function. This is my function defined as y equals f of x. And what we're doing, we're finding the area under the curve. So it's like the man them who, as I explained to you, I try dig wrong for go put under the car park. All right? And them know say, here the plan. The property boundary is from A to B. We can't go over Yasso, because over Yasso is somebody else one. We can't go over Yasso neither, because of some our neighbor property that. our property line is from A to B. All right? Follow me so far?
Yes, sir.
All right.
Jeremy, just like one listen.
All right. Watch me now. It's not hard, man. I'm going to give you an activity to do right now. You're going to get it. The width interval from A to X1, from X1 to X2, from X2 to B have the same width. From Yasso to Yasso are the same distance from Yasso to Yasso. Same distance from Yasso to Yasso is the same width, right? So we can't have this trapezoid. All right, thank you, Auntie. All right, thank you, Auntie. Sorry about that here. So we can't have this trapezoid, one little piece right here, so, and they want big something here, so, and they want, it must be the same width interval. Must be the same width interval. So I'm going to go and read now. I have an activity to give you. So we're going to let f be a continuous function on the interval AB. Sir, continuous function? Yeah, man, we did look on that in a calculus one. Let me show you what a continuous function is, though. You notice that there is no break in this function. You notice that this thing just goes straight up, boom, 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 come right round, and there is no break. And how you know that there is no break? You can use a pen or a pencil, any writing implement, and you can make the shape continuously without lifting. You see the moment you lift the pen and to go join back to that is going to be the break. That's going to be, and that break is known as a point of discontinuity. But in this case, you're drawing the stuff. Oopsie daisy, I shouldn't do that. Oopsie daisy. Come on, Mr. Shan. In this case, you're drawing the thing all the way without lifting. So that is what is called a continuous function. All right, there's no break in the function. So if f is a continuous function over the interval AB, sir, where AB come from? Okay, good question. See, starts at A, ends at B. Then something here is just to divide the division, something then. Starts at A, ends at B. Sir, why? Okay, good question again. Because remember, from A to B is where your property line is. If you go over B, are your next door neighbor? And if you go over A, are your next door neighbor? This is your property line. This is all that the man can use, nothing more. All right? So, continuing. It says the trapezoidal rule for approximating the integral of f of x, the function, over the interval, the upper limit, which is b. The upper limit is a bigger number. The lower limit is a. And I'm integrating that function with respect to x. I call it dx. So that formula that you see right there, or the function that you see right there, is nothing strange to all of you. It is going to be the integral of f of x, the upper limit b, the lower limit a, written over the elongated s, which is the sign of integration, and the dx must be written because it says that I'm integrating with respect to x. And then now, what I did was to define what all of this is going to work out to be. And you have this ugly, 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 ugly looking something here. Oh, the 12 one in a class. Is that 12 one in here? More the 12 one now. Go put up on the left hand. Missy, are you right-handed or left-handed?
Left-handed, sir.
Nesta, right-handed or left-handed?
Right-handed.
All right, good. So I want both of you to put up your left hand then. And all of what I'm doing here, I'm going to explain it in one of this, in this one exercise. I want you to work with me. I want you to put up your left hand. And I want you to look at the palm of your left hand. It's supposed to be facing you. your thumb, when you stretch out your hand, your thumb may almost be at a 90-degree angle. But I want you to push up your thumb a little bit so that the thumb almost is pointing upwards like the other 4 fingers. Are you with me?
Yes, sir.
Missy, are you with me?
Yes, sir.
All right, hold it. Your thumb, let me go back down here. So your thumb, sure, is going to be your A. Hold on a minute, please. Yes, uncle? Hold on. Hold on a minute, please. Oh, yeah, man. Thanks. Appreciate it. Just gonna- Auntie Beth, bring her here. Alright, so you do something already. No, full around it. Yeah, man, no problem. We'll definitely come and get something. Hold on. Yeah. No problem. We'll definitely do that. She is on the. She's on the tablet with her. She's not gonna eat now. But when I'm finished and I come, both of us will sit down and eat, man. Fret not. I appreciate it though. Thanks. Good. Are you hungry? I think I just unplugged something. Did you plug it back in for me? Hello? Hello?
Yes, sir.
Anybody hearing me? All right, sorry about that here. So where was I? Yes. So I want you to put your hand up, and so I don't want your thumb to be pointing to the left. Your thumb's supposed to be pointing in the opposite direction as your other 4 fingers. So your thumb is going to be your A, and your pinky is going to be your B. All right? So your pinky, if you count your thumb is going to be 1, the index is 2, the middle is 3, the ring finger is 4, and the pinky winky is 5. So when you're writing it, you're going to have 5 as your B, because B is the bigger of the 2 values. And your A is going to be 1. And you see the inside fingers, the index, the middle, and the ring are the divisors. All right, so watch me. I want you to look, and I want you to count with me. Between the thumb and the index finger is going to be 1 trapezoid. That's 1 trapezoid. Between the index finger and the middle finger is going to be another trapezoid. So we're going 2 trapezoids already. Between the middle finger and the ring finger is another trapezoid. So we're going 3 trapezoids. You see your ring finger to your pinky winky is another trapezoid. So we're going 4 trapezoids. Do we have another set of trapezoids there?
Oh,
Talk to me now.
well,
No, we
sir.
don't. Right, very good, we don't. All right, so we don't have another set of trapezoids. All right, now, when you look at your index finger, how many fingers are surrounded by your index finger?
Two others.
Huh? Talk to me now. How many fingers are surrounded by your index finger?
Sir, I said two others.
Okay, I didn't hear you good. Good. So two others. Very good. How many fingers are surrounded by the middle finger?
Middle finger. Two others.
How many surrounded by the ring finger?
Two.
All right. Very good answers. Hear me out now. How many surrounded by the index finger?
Index finger again.
Not the index, a pinky winky, sorry.
One.
All right. All right. And how many surrounded by your thumb?
One.
Excellent. Excellent answers, Missy. All right. Watch me now. You notice I have two things in blue. This one here in blue and this one here in blue. This one is your thumb. It is only surrounded by one other finger, which is your index finger. So I don't have a two right here. So the index finger is surrounded by two other fingers. So that's why I have the two right here. So the middle finger surrounded by two other fingers. That's why I have the two right here. So the ring finger surrounded by two other fingers. That's why I have the two right here. So and then I put the plus because I can go all the way up. And then the index finger, the pinky winky finger is surrounded just by one finger. So I don't have a two right here. So notice that only the first one and the last one don't have a two because those are not surrounded by any other finger, set of fingers. Does that make any sense? With the illustration I gave you with the hand just now and showing you the formula so far, does that make sense to you?
Yes, sir.
All right, good. Missy, what you say?
I agree, sir.
All right, good. So now I can go read the rest of it for you. So this is what the formula says. So it's going to be f of x0, then x1, then x2, then x3, then x4, then x5, so forth and so on. But remember, so the first one don't have no one, but every other one is going to be multiplied by 2 with the exception of the last one. So the first one and the last one will not be surrounded or multiplied by a 2. All right? Now, delta x is going to be used to find the width of the trapezoid. See? Delta x is going to be used to find the width of the trapezoid. Remember earlier I said to you that I know just any random and arbitrary lies. It's not any random and arbitrary size. The width works out to be. It is particular. It is calculated. So the width for this first trapezoid is equals to the width of the second trapezoid is equals to the width of the last trapezoid. So the trapezoids have equal width. So now delta x is going to be used to calculate the width of the trapezoid. How do we calculate it? It's going to be b minus a over n. B is the upper limit and a is the lower limit. And n is going to represent the number of trapezoids. N is going to represent the number of trapezoids. B is the upper limit. A is the lower limit. And N is representing the number of trapezoids. And N is representing the number of trapezoids. Talk to me.
Yes, sir.
All right, good job. So delta x is going to be equals to b minus a over n. B is the upper limit minus the lower limit divided by the number of trapezoids. And that is going to give you the width of the trapezoid. When you calculate that, you know, so everything will have the same width. You never have one different value than the other, negative. Then we have the same width. All right? Continuing. The area of any trapezoid is going to be half the sum of the parallel side times the perpendicular height. And that's how we calculate the area from within CXC maths and the formula we use. A is equals to half the sum of the parallel sides times the perpendicular height. We won't use this formula here, but this formula is going to be used to help us to remember what is happening on the inside. Here, there. The reason you see all the tools in the trapezoidal rule is that every base is used twice for consecutive trapezoids, except for the for the bases at the endpoints. You see this two-line statement here is exactly what I just asked a while ago. So I'm translating it for you. What is the translation again, sir? Put up your 5 finger then. Don't let the thumb spread all the way out like a 90 degree. Cause your thumb to go in the same direction generally as your other fingers. Open your fingers slightly. Don't close them up. Open your fingers slightly so you can have a space between them. And the spaces that you're looking between them is going to be your trapezoids. Here my question to you. How many trapezoids are you seeing therefore on your left hand? Put up your left hand again and tell me how many trapezoids you're seeing there.
Wait, where is this?
I'm saying put up back your left hand again.
Yes.
Put your thumb in the same general direction as your other fingers. Slightly opening the fingers. Don't let the fingers kiss. Let them be apart, not fully, but slightly apart. How many spaces can you see between? How many trapezoids? Remember the trapezoids are inside. 4 spaces. Very good. So you guys are following it up. I am breaking down everything that I have on the screen with just one hand movement. So you have 4 spaces. Excellent. The trapezoidal rule overestimates. Okay, before I go there, I just need to clear this up first from day one before I move into this question. Because we're moving into a question now. Keep your left hand up. Keep your left hand up. Don't change it. Keep your left hand up. How many fingers do you see? And for now, we're going to call it thumb a finger to here. We're not going to get smart and say, sorry, it's not a finger, that's a thumb. We're going to call it a thumb, a finger. How many fingers are you seeing?
5.
Very good. How many trapezoids are you seeing?
4.
Or spaces between? Very good.
4.
Hear me up now. So you're seeing 4 spaces between your fingers, but you have 5 fingers. So you know one is less than the other. One is 4 and the other one is 5. Talk truth.
Truth.
All right, good. So the spaces in between are called trapezoids, and you have 4 trapezoids. Your fingers will represent your ordinals. So a little later on, you'll hear me speak about ordinals versus trapezoids. Your ordinals will be one more than your trapezoid. So let us look again. Your fingers are representing your ordinals.
Sorry, may I write it down?
Oh, okay. So your fingers represent your ordinals. So you have 5 fingers up. Your fingers represent your ordinals. And the spaces between fingers represent your trapezoids.
Okay.
So when you look at it, all in the exam, you can just put up your hand and look at it. 1, 2, 3. You have 4 spaces but 5 fingers. It means that the number of trapezoids will always be 1 less than the number of ordinals. Or I can say it another way around. The number of ordinals is going to be greater than the number of trapezoids by 1. But N is representing the number of trapezoids. And that last piece that I just talked about a while ago is significant, you know. It's very, very, very significant in evaluating the solution to your question. Very, 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 very significant. And a lot of students, calculus 2 students even, go into the exam and make that mistake. You see this explanation that I'm just giving you? This explanation that I'm just giving you came to me in second semester this academic school year. Mute, Missy.
Oh, sorry.
This explanation came to me in second semester of the school year. When I was teaching the topic and nobody not get it. I said, John, no. I said, oh, do this, do that. The same thing that I just asked you to do. I went through with them. And I said to them, do this, do that, do this, do that. Some of them catch it. But some of them going exam and go to foolishness and lose the mark. And I'm saying to you, if only you remember what I'm saying to you here, you're good to go. The spaces between your fingers represent the number of trapezoids. That is represented by delta x. Delta x is always b minus a divided by the number of trapezoids. Make sense?
Yes, sir.
All right, watch me now. Example 1. So we're going to use the trapezoidal rule to estimate that something here. This is the integration that they want us to estimate. And then say n equals 3. N equals 3 is suggesting that I have three trapezoids. Remember, n is representing the number of trapezoids.
Yes, sir.
Oh, good. So watch me now. So if I have 3 trapezoids, Lower, how many ordinals are we going to have?
4.
Excellent. Watch me now. Why not count with me? This is an ordinal. 1 function here ordinal. 2 functions. 3 functions. 4 functions. How many plus signs I have there?
3.
The number of plus signs is going to correspond with the number of. Me actually, let me put something so I can't get it, you know. So you see, this is like a thumb and your index finger, and the space between the thumb and index finger is a trapezoid. Remember when we just showed you a while ago?
Yes, sir.
The index finger and your middle finger, and the space between your index finger and your middle finger, you have 1 trapezoid. And then you have a middle finger and your ring finger, and then you have a space right there. So, right? So remember now, you know, you remember say the first one and the last one now go multiply by 2 because, and that's why only them 2 you have the 2 multiply right there. So. Yeah, man, Mrs. Say, but click on me and look on it again.
So, oh yeah, I put up 4 finger in this case.
Ah, very good. Yes, man.
Okay.
Only 4 fingers are put up in this case. Because why? You have only 3 trapezoids. So you have 3 trapezoids. The number of trapezoids is going to be 1 less than the number of ordinals. So if you have 3 trapezoids, that means you have 4 ordinals. Make sense?
Yes, sir.
So this is it now. We're calculating the width of the trapezoids. Remember, it is the upper limit minus the lower limit. So the upper limit here, 2. The lower limit here, -1. 2 minus -1. Look at that and to see. All right. Now, 2 minus 1 all over the number of trapezoids. Remember I said to you, n represents the number of trapezoids. So if the total that n up here says 3, that means we have to divide this by 3. So let's just check. 2 minus 1 becomes 2 plus 1. And 2 plus 1 is 3. And 3 divided by 3 equals 1. So
So you
now,
not get that if you put all at night at once.
yeah, man. Put 2 minus 1, you're supposed to get 3.
Sorry.
Sorry, sir. Good night. So I'm having some of the internet issues. So I just connected to my data. My internet is giving me some problem. So sorry for the late class.
No problem. No problem. Next, try it for me, please. Put it in and tell me if you get it.
Sure, I'm gonna get it.
All right. Clear your calculator.
Sir, I'm gonna get it when I separate them, you know. Like if I put everything in it, like 2 minus 1 divide by 3, so it give me a different answer. But if I separate them, I get the 1.
Good. So because, all right, work for me, do it for me. Put 2 minus 3.
2 minus.
I think it about use the Bombas rule applies there too, sir. For the division,
Yeah,
work
yeah.
out first, and then the minus work out first. And that's why it's
So next, do me a favor. Put the 2 minus 1 in parentheses. Put open parentheses, 2 minus 1 and close it. And then press divided by 3 and take it now.
Yes, sir, it worked.
Yeah,
Okay.
man. So it's just how you put it in on the calculator.
Okay.
So that tells us the width of the trapezoids. So each trapezoid is supposed to be 1 unit long. So watch me now. This minus 1 is my starting point. See that so? You remember, you know, we have 3 trapezoids. That means how many ordinals are supposed to have?
4.
All right. Our starting point is -1. See right there so? When you add this one to -1, what do you get?
Zero.
See that so? When you add 1 to 0, what do you get?
1.
When you add 1 to 1, what do you get?
2.
See that so? Can we pass 2?
No, sir.
Why?
Oh.
You see? 2 is the upper limit. 2 is the upper limit.
Okay. Yes, sir.
So what I'm saying to you, if you go over 2 and your neighbor you're there going now, pass. Police never go call upon you. So that's how we calculate the width of the trapezoid. Take a minute and look through all of these 3 or 4 lines that I have here before I continue the question.
Wait a sir, the trapezoid is the space between the ordinals or the lines.
Very good. Actually,
Yes, sir.
I just pick up your message in the WhatsApp group.
Oh, okay. Yeah.
And then me take fast and look on your display picture. And you know, say everyone in the class look on your display picture. And, you know, so my bad minding right about no, right about no, my bad minding. Anyway, go for this. Right about no, my bad minding. Anyway,
Stay
you
a
go and
long
take the
time,
picture.
picture, no?
I don't care. Anywhere you go,
Time.
I am bad man at this point. Trust me. Time hot, bad man. Time hot. All right. Look at that and I'll give you 2 more minutes and then I'll come back to you.
Okay. Sorry, I can't find the I think the second class video. Are the video them uploaded from
Can't find the
the
video
first class?
from the
Yeah.
first day, your man up. You can't find it?
Because why not put the topic them on it? Because me I feel I run through like add the topics like
Yeah.
to the thing. So you can easy to
Yeah.
find.
So what I do instead is just put the date because sometimes the time when I get to upload it, I can't got into it. So that's why I put the date up top.
Oh,
So if you notice,
that's it.
right, so you notice I put math 4702 calculus 2 semester this and that. So at least you know which one we're looking at. But I guess if I get a chance I can go in and just do that for you. But yeah. All right. 2 more minutes.
So I can just use a quiet sign that they're working to just explain, or just give me a little brief update on what's happening with this topic, please.
All right, Ottilie, no problem. I can do that for you. All right. And guess what?
You can continue, sir. I'm right
And-
off up to where the line is.
All right, no problem. So Ottilie is asking for a little update. So I'm going to use the opportunity to go through with Ottilie and those of you who didn't see something will now have an opportunity to see it again. So Ottilie, put up. Are you left-handed or right-handed?
Right-handed.
Okay, put up your left hand for me, please.
She right-handed. Oh, she left-handed.
No,
I'm
she right-handed.
right-handed.
So I ask her to put up her right. So I ask her to put up her left hand. Put up your left hand for me, please.
Okay.
The palm of your hand is supposed to be facing you. You're supposed to be able to look at. I want you to put it in front of your face. You're supposed to be able to see the palm of your hand in front of your face. Now, normally when you
Okay.
put out your hand, or thumb is normally pointing, you know, in a westward direction. If you put up your left hand, we don't want it point away from the other four fingers. We want it point in the same direction as the other four fingers. So use the right hand, since you're right-handed, and just push your thumb up so that the thumb is pointing upwards like the other four fingers. So they're called
Okay.
thumb, index, middle, ring, pinky. All right. Now,
Yeah.
how many spaces are you seeing in those in that left hand or between fingers?
1, 2, 3, 4. Well, 4, because that 4, 5.
Right, so it's in 4 spaces.
1, 2,
What?
4 spaces. 4.
Okay, good.
4
So it's
spaces.
in 4 spaces, right? So those 4 spaces are
Yeah.
called your trapezoids. Those 4
What is
spaces
it
are
called?
called your
Oh,
trapezoids.
trapezoid.
Yeah, trapezoids, right? How many fingers do you have up?
5.
Very good. So you recognize that you have one more finger than the number of spaces between the fingers?
Yes.
Okay. So what we're saying to you with this topic is that we have the number of the spaces between your fingers. Is that right? The spaces between your fingers is called your trapezoid,
Yes.
and the fingers are called ordinals.
Ordinals.
Spaces,
Okay.
or ordinals, right? So the spaces between your fingers, they are called ordinals, and your fingers are called your rubbishness. The spaces between your fingers are called your trapezoids, and your fingers are called your ordinals. So you have one more ordinal than you have your trapezoid. So in this case, you have 4 spaces, which are 4 trapezoids. You have 5 fingers, which are 5 ordinals. So you have 4 trapezoids, but 5 ordinals. All right? So just remember that.
Yeah.
So it's something that we have to remember when you're doing this topic. Ordinals, trapezoids. Ordinals, trapezoids. Ordinals, trapezoids. Ordinals is more than the number of trapezoids. One more to be exact, not 2 or 3. Just one more than the number of trapezoids that we have. All right. Now, one of the other things is that how many fingers is beside your thumb?
1.
Okay. How many fingers are beside your index finger?
1.
Your index finger.
Oh, 2 index. 2, sir.
How many fingers surrounded by your middle finger?
2.
How many fingers surrounded by your ring finger?
2 fingers, sir.
How many fingers surrounded by your pinky?
Just 1.
All right, good. So if you've answered me correctly, in all of those responses, you've answered me correctly in all those responses, right? Now, this is what it is that I want you to do for me. When you look at your question, you will see numbers. If you like this 2 here,
Yes,
this
sir.
2 is right here. So because it is surrounded by 2 things, or put it this way, a better explanation to that is the first, you notice your thumb and your index fingers just have 1 finger surrounding them. So it's just 1.
Yes.
That's why the first term and the last term have just 1 in front of them. And everything else inside the middle may have 2. Look back at your hand. It's just a first, it's just a thumb and your pinky winky. Don't have 2 fingers surrounded by them. Talk truth.
Right.
Talk truth, yeah?
Sure.
So that's what the formula is.
Okay.
That's what the formula is. All right. And pretty much that's the basis of it.
Okay. 4, 2, 1, 3, 3. So then the triangle represent the
All right. So now that you've gone to that, no. Delta X is representing the width of the trapezoid.
Okay.
So delta X, when I calculate delta X is telling me how wide the trapezoid is supposed to be.
Okay.
So delta X is actually talking about the width of the trapezoid. And how we calculate delta X is going to be the upper limit minus the lower limit divided by 2. That divided by the number of trapezoids. That the upper limit minus the lower limit over the number of trapezoids. The divided by 2 is a different thing. Right, the divided by 2 is a different something. That's what I was going to move on to next. Right? So you notice this is being divided by 3 here, because when I'm calculating delta X is going to be the upper limit minus the lower limit divided by the number of trapezoids.
Okay, which is 1, 2, 3. Okay.
Which is 3.
So we can actually find that thing on the calculator. So
what, delta X?
the delta X.
No, you don't need it. You just actually take a quick time.
Okay.
Quick time. Yeah, man. Quick time. Just 1, 2. Easy 1, 2 that. Easy 1, 2. Oops, and you're done. Right? Oops, and you're done. And then now we're talking about the ordinals now. How do we calculate the ordinals? The ordinals are going to be found when we look at what it is that we have. The ordinals are going to be found when we look at what it is that we have. What do we have? We're starting at -1. Our starting point is at -1. Our starting point is at -1. So it's going to be -1. We have to start at -1. Because -1 is the lower limit.
Always.
Yeah, man, you always start at the lower limit. You always start at the lower limit, and you will always end at the upper limit.
Okay.
You always start at the lower limit and always end at the upper limit.
This draws the weight of the trapezoid endpoint. Which. Trapezoid. End point.
Waiting on you to tell me.
Yeah, sir.
All right. Now, so if I start at the lower limit, the lower limit is going to be -1. Remember, I calculated my endpoint a while ago to be 1 because remember it's 2 is the upper limit minus the lower limit. So it's going to be 2 minus -1. 2 minus -1 is the same thing as 3.
3, yeah.
And 3
And
divided by
2
3 is equal to 1.
Mm-hmm.
And 3 over 3 is going to be equal to 1.
So you get the ordinals to be those values.
All right. So you notice what is happening there now is it starts at the lower limit, -1, and we add the lower limit to this number, to the delta x. So -1 plus 1 is?
-1 plus 1, 0.
That's how we get the second ordinal. And we'll add the second ordinal to this. 0 plus 1 is?
1.
And so we get the third one. 1 plus 1 is?
Oh, 2.
And we get this one. Should I say 2 plus 1 and get 3 right here, so?
Let me see.
Say no. Say no.
Why would you not? Because why wouldn't you?
All right, that's what I want to say. So I want you to say no, and then I'm going to ask you why.
No, but I don't know why.
Because the upper limit is 2.
Upper limit is 2, so stop at where the okay.
Right. So you notice
Right.
if you notice the lower limit here is -1, and the upper limit is 2. See here, the lower limit is -1, and the upper limit is 2. It can't be less than the lower limit, and it can't be more than the upper limit.
2 minus -1. 2 minus -1 is. I missed. So where I missed was where you got the 2 minus -1.
There's the upper limit. The upper limit,
2.
which is 2, minus the lower limit. So it's 2 minus the lower limit, but the lower limit is -1. So that we have the 2 minus -1.
Okay. So basically, we have to work in it out. They can really test it to see if you do the correct thing.
True.
Okay. Okay. And then we call f of x. The x squared to the original formula -3. And then substitute it. The ordinal, sorry.
The original one.
The original?
Then you want to have original?
Ordinal. Oh, I'm here, Mark. Okay.
My explanation just now, Missy and Nestor, it made it resonate a little bit more with you.
Very much so.
The ordinals?
And
Yes,
and
sir,
the delta. Yeah, man. Very nice. Very nice. Very nice.
So how much this I got mark? Right. Come here for try my port when I go. When I have to strong up and for exam.
About 10 marks, you know. The question comes about 10. Anywhere between 5 and 10 marks. Sometimes 8 marks, sometimes 10 marks. Enough marks that one.
Is it a must that them give in an exam?
Me think so, you know, yeah, man. Me think so.
I
think so. It'll come, man. It'll come.
Okay.
It's a home.
So every time you add the lower limit until you get the desired
Very
trapezium.
good. The desired ordinals.
The desired ordinals. The
Yeah, man.
ordinals are the
Ordinal.
Yeah, you remember you started the lower limit, -1, and you're adding it to the width of the trapezoid. So
So I
-1
can
plus
go
1
down
is
a
0.
little bit now.
No, I don't reach
Oh,
on here yet. I don't reach on here yet.
okay.
And then what is happening here now is when I have the -1, which is my starting point. My starting point plus the width of this ordinal is saying -1 plus 1, which gives me the second ordinal. And when I add the second ordinal to the width of the trapezoid, 0 plus 1, I'm going to get 1. So it gives me the third one. And when I add the third one to this, 1 plus 1 is 2, we get the 1 here, 2. But somebody will say, but sir, why not say 2 plus 1 get 3? Me can't. Because guess what? I end at 2. So when you look at my stuff, my starting point and my end point supposed to be very close. My starting point and my end point supposed to be very close. They're not very close, supposed to be exactly the same. Because if I start at -1, see to your son, -1. And I end at 2, see to your end at 2. But the numbers inside here are going to differ. The numbers inside here are going to differ. So
Sir,
now, go ahead.
the equation that you have, the second line where you have where you said the trapezoid, where that explained to me, so the 2f and the x that goes all the way up to 3, is that because n is equal to 3?
Very good.
Okay.
Which x you talk about that goes up to 3?
The second line,
this
yes.
here?
So you have, yes, you have x.
No. This here, very good question, but no, I won't tell you what happened. This is my first, all right. So these are my ordinals. 1, 2, 3, 4.
4.
Is the ordinal there? 1, 2, 3, 4. Only them 2 middle piece here, okay, multiply by 2. See here, so the 1 you multiply by 2, the 1 you multiply by 2, and the 2 end ones are going to do that. But I have this 3 here because my first one is x0. So if my first one was x1, I'll go x1, x2, x3, x4. Sometimes I give you the starting point as x0. Sometimes I give you the starting point as x1. So if they give you at x0, it's going to be 1 less than the number of ordinals. If they give you at 1, you get, but don't worry about the x1 and the x2 and them, something they just get.
Okay,
that is fine. Yeah, man. All right. Now I will be able to go down.
Yeah, substitute.
Hold on a minute. All right. Now I am going to beg an opportunity to inhale some food as I'm very hungry, and I'm not going to be able to hold out until the end. But I'm going to give you something to do for me in the meantime, though. I just want to explain the end of this question now. I want to explain the end of this question. And I want you to give me an opportunity again, just like you did before, for me to just go through the explanation. You see them ordinals there? Respect them. Respect the ordinals. Because at them there, you will substitute into the function. But now the integration, this is just an approximation to integration. The ordinals is what we're going to substitute into the function. So see the function here that was given, x squared minus 3. That's why I recall it. I'm recalling it because this is what was given. So look at what will happen now. I'm going to substitute this first ordinal, -1, into this function. Anywhere I see x, I put -1. It's -1 squared, which is +1. +1 minus 3 is -2. See it right here. So boom. Then I jump to the second ordinal as 0. Anywhere in the function I see x, I put 0. 0 squared is 0. 0 minus 3 is -3. See it so? Boom. -3. I move to the third ordinal, 1. Anywhere into the function I see x, I'm going to put 1. So I'm going to have f of 1. See here, so f of 1 is 1 squared, which is 1. 1 minus 3 is -2. Boom, -2. And I move to the last ordinal, 2. Anywhere in this function I see x, I put 2. So f of 2 is equal to 2 squares minus 3. See here, boom. 2 squares is 4. 4 minus 3 is 1. So them number here in blue, important. Watch me. So you know that the first one and the last one don't have the numbers multiplying by them. They don't have any numbers at all multiplying by them. Because, and I should do something here, I just want to highlight the fact here. Seeing that I'm not in front of you, I want to highlight it so that you can see what is
Now we're
happening.
going to plug each ordinal into the function.
Very good. Very good. All right. So you notice the first one not have no 2 multiplied by it, and the last one not have no 2 multiplied, because when you look at your thumb is only surrounding one finger, and your tinky winky is only surrounding one finger, but the other 2 will be surrounding 2 fingers each. So that's why that is that. Watch me. You may say, sir, hold on there now. I see 1/2 outside here, so where you get it? This won't come to board one day. Kind of excited, I just want to finish this now. So look at what is happening now. This -2 is this -2 here. This 2.
Tell me know where the half come from.
Where come from?
You see the triangle with the X? We have the triangle with the X. Yeah, that?
You put it over 2, right? You just put it over 2.
It equal 1, yeah.
I just put this over 2. Very good.
Yeah.
Excellent. So the number that the factor of this sum here is always going to be triangle x over 2. So anything the width of your trapezoid comes out to, you're going to divide it by 2. So if the width of the trapezoid come out to 1, you're going to have 1 over 2. And that's how we get this half here. So if this here comes out to be a fractional number, you're going to have a fractional number up here divided by 2. So every time, sir, you're going to divide it by 2 to get this one. Yes. So anything you work out the width of your trapezoid to be, and you divide it by 2, that's what it's going to be in front of it right here. So very good, Chin Chin. Right? So that's how we end up getting the 1/2 here. So because delta x, which is the width of the trapezoid, is 1. And then it said divided by 2, so 1 divided by 2 is 1/2. So the half is carried forward. And 2 times -3 is -6. 2 times -2 is -4. and this one stands alone, just like the first one. That -2 plus -2 plus -6 is -8. -8 plus -4 is -12, and -12 plus 1 is -11. This is it. And then 2.5 times -11 is -11 over 2. So this is going to be my approximation. And let me just show you something very quickly before I give you one to do and before I go eat a little food. This is a question. I'm doing the actual calculation. I'm doing the actual calculation. See? One time calculus class here, add 1 to the power divided by the new power. Watch me. X to the third divided by 3. See here? X to the third divided by 3. You're adding 1 to the power divided by the new power. This is going to be -3x. See here? -3x. My upper limit is 2, lower limit is -1, 2, -1. Remember, it says to substitute the upper limit into the. No man, this is a calculus one, you know.
No, before I reach a part, the matter.
Before we reach this,
Go back up a little more.
no man, the question. Oh, come on, what is wrong, man? The question finish here, saying, love. See yourself?
Oh, a different question that you did 1 while ago.
Yes, man. May I show you one different
sorry.
calculation now? Yeah, man. So what I'm showing is the actual calculation now. So the one up top was an approximation. So I'm showing you the actual calculation now. That's something not treat me right tonight, you know. I'm showing you the actual calculation now. To show you that what we do is correct. So remember, for calculus one, when you're doing the actual integration, the rule says you add 1 to the power and you divide by the new power. So this x squared is going to now become x cubed divided by 3. X cubed divided by 3. And this -3 now, you're going to add an x to it because what you'd have had there is like an x to the 0. So you're adding 1 to the power, so it becomes x. See here, -3x. Then you have your upper limit, your lower limit. So you're going to substitute your upper limit into the function. So you have 2 cubed over 3, see it right here, so? -3 times 2, see it right here, so? Minus, you have -1. -1 cubed over 3, see it right here, so? -1 cubed over 3. -3 times -1, see it right here, so? Boom. I don't need to have it here because I've already substituted my upper limit and my lower limit, so I can take that off. All right? Watch here. So I took off the wrong one, undo. Took off the wrong one. That's why I'm supposed to do. I'm not rushing now. All right. So now that I've made my substitution of my upper limit and my lower limit, they're not supposed to be here again. All right. Then we're going to evaluate here. 2 cubes is 8. I have 8/3. And -3 times 3 is -6. Boom. I have that there. -1 cube is -1. So it's going to be -1 over 3 right here. And when I multiply two negative numbers, I get a positive number. -3 times -1 is +3 right here. 8 over 3 minus 6 is going to be -10/3. And -1/3 plus 3 is going to be 8/3. And -10/3 minus 8/3 is going to be -6 units squared. So the actual calculation gave me -6 unit squares. But when I did the approximation, it gave me -5.5 because 11 over 3 is 5.5. So what it says, remember the topic says approximation, you know. So it's only giving me an approximate value. It's not giving me the actual value. So this here is giving me an approximate value to be, what am I call it? To be -5.5. Something just comes to mind a while ago, and I may give you that to do for me as homework. I don't have it in my notes. but I'm gonna generate it now. I don't do it yet, so I may have to just sit and do it while I. All right, so I'm gonna give you the same question to do. I'm gonna give you the same question to do. Copy. Giving you the same question to do. But this time, you know what I should do? I should just copy all of this into the solution. I'm going to give you that same question to do. Copy. And then what I want you to do for me in doing that question is, as my example tool, I'm going to ask you to instead of using 3, I want you to use n to be 6. Instead of using 3, I want n to be 6. Let me just put that in a different color so you know that's what I'm changing. I want n to be 6. So
Okay, can you come up a little bit more first?
no, what I'm gonna do, Nestor, is the only thing that I'm changing for the question, not Nestor, utterly. The only thing that I'm gonna do for the question is put n equals 6. So you're gonna go through the calculation for me, and I'm gonna project the question. I'm gonna project the question. You're gonna go through the calculation. I'm just trying to minimize it so everything holds on one page. And it now will show, well, one more. You may just need to zoom in order to see it. All right, got it. So in the first instance, what I did was when n equals 3, I want you to replicate that question for me and use n equals 6, and then again compare the answers and see what it gives us. Is that understood?
Yes, sir.
All right, good, thanks. All right, so I'm going to try inhale some food. So I'm here, I'm listening to you, so you can speak to me. If you have a difficulty, I will respond to you. Hi guys, are you okay? You've been on with the question? Okay.
Show me what thing when that go and try understand.
All right, that's all. No problem. All right. So I'm just getting a bite.
But sir, me have to leave in a while. Here we can go up to 9. I have to leave work.
All right, no problem. It's no 8:30, so that's fine.
Okay, sir, just sorry, me step away a little bit, but me I work now. Question to us, sir. Is it that we're getting a test next week or so? Sure, no?
I want to give you no, I want to give you your mid semester, which is going to include the
Maybe next year.
okay, right. All right, no problem. Right. I want to give the mid semester, but I don't want to give the mid semester until I know that you guys comfortable with the topic, because this topic is on the mid semester. So if it means that I need to go through it one more time, fine. But just still hope that you can get through to this first. That's what I was saying to you in the WhatsApp. Remember I answered your WhatsApp?
Oh, I mean, I look on it, sir, but the reason me I ask because I pay night shift, me see for me something. So I have to try to see if when I give the mid semester, so I can look at day after that day.
All right, no problem.
Okay.
Ottilie? Nesta? Ottilie? Nesta?
Oh, shoot. Sir, I'm here, sir.
How is it going? You sound like you dozed off a while ago, man.
Yes, sir, sir. What?
Yeah, that's all right. Nesta? Nesta look like she's gone too. No man, all
All
right. So
right.
what I want you to do, just if you can just finish off that one. Just that one question and then we just end off.
Okay, so
Yeah, man.
okay. I don't, I still don't think I'll get the second line properly. Serious thing when I get here, so I'm gonna work it and see who or -0. Still gotta put this. Don't think we get the plan.
The young lady. Ottilie, are you finished the work now?
Sir, no.
Ottilie?
Yes, I'm here. I'm trying to get it up, but
No, let me see.
me still I try to figure out this part of it because I think me somewhat not understanding. So when where the n equal to comes into play in the equation, into working it,
All right, do me a
because you
favor.
change the
I
yeah, go
think
ahead.
part of the problem, is that you're very tired. So I'm gonna recommend that you go get some sleep. Allow me to work the question out fully and then send it off to you so you can look at it. Part of the problem is that you're tired. And I mean, you have a right to be tired because you work. So go and go get some rest. And then I'll do the solution
Okay.
and then send it off to you. All right?
All right. So
All
thanks.
right, cool. Mhm.
Sam, I don't even know how to.
Because all I know is that somebody pressed the level.
I don't know how to press the lever.